Hello friends, I am Suneeta Phadkule, Professor in Mechanical Engineering, working at JSPM's Jaywantrao Sawant College of Engineering, Hadapsar, Pune. This is our video lecture number 37, which is on unit number 4. Today's topic is numericals on balancing of radial engines. We are going to study graphical method, that is direct and reverse crank method. Okay. The learning outcome is you will be able to analyze the unbalance of radial engine using direct and reverse crank method. Now let us see the recap. In the earlier lecture, we have studied analytical method for balancing of V engine. Okay, so we have derived these formulae, how to find out primary unbalanced force and then secondary unbalanced force for V engine. Okay, then we have also studied direct and reverse crank method for radial engines. Okay, it may be 2-cylinder engine, 3-cylinder engine, 4-cylinder engine, but it is a radial engine. Okay, now see, there we have studied primary unbalance and secondary unbalance, how to balance the forces primary and secondary for single cylinder. If you remember in the earlier lecture, we have studied that this is the direct crank, this is a reverse crank. Reverse crank is a mirror image of direct crank. Okay, both are making angle theta in the opposite direction. Okay, and using this concept, this is direct and reverse crank, we have found out what is the unbalanced force present in the system. How much is the primary unbalanced force and how much is the secondary unbalanced force. Now this we have studied only for single cylinder engine. That means we have studied only concept. Now here we are going to study how to apply this concept for multi-cylinder radial engines. That means there are more than two or more than 2 cylinders arranged radially. Okay, so through the problems only we are going to study it. So let us see first problem. The 3 cylinders of an air compressors have their axis at 120 degree to one another and their connecting rods are coupled to a single crank. The stroke is 100 mm and the length of each connecting rod is 150 mm. The weight of reciprocating parts per cylinder is 15 Newton. Find the maximum primary and secondary forces acting on the frame of the compressor when running at 3000 RPM. Describe clearly the method by which such forces may be balanced. Given data is stroke is given 100 mm. That means radius of crank is half of the stroke, that is 0.05 meter. Then L is the connecting rod length, that is 0.15 meter. So from L and R, we found out N, that is obliquity ratio. It is 3. Then M is given 1.53 kg. Okay, that is Newton divided by 9.81, that is mass. Then speed of the engine is 3000 RPM. From this, we have found out omega. It is coming 314.16 radian per second. And we have to find out primary unbalanced force and secondary unbalanced force by using which method? Direct and reverse crank method. So this is the configuration diagram. So these are cylinder number 1, cylinder number 2, cylinder number 3. These are making 120 degree angle with each other. Okay, and this is a radial engine because all the here connecting this line of strokes are radial to each other. That means those are falling on the radius of the circle. Okay, circle in which your crank is rotating. Crank is a common to all these 3 cylinders. Okay, now let us the first step is you have to write down the table. See, this method, direct and reverse crank method, is very simple, but you have to get understood the concept, on which concept it is based, which you have already seen in the earlier lecture, but that was for single cylinder. Now here you have to apply this concept for this 3 cylinder. Okay, so let us study this table. There are 4 columns. 2 columns for primary crank, 2 columns for secondary crank. So under the primary crank, there is a direct crank and there is a reverse crank. Again, in the secondary crank, there is a direct crank and there is a reverse crank. Okay, and based on these 4 columns, we have to draw 4 diagrams. That is known as a direct primary crank diagram, reverse primary crank diagram, then direct secondary crank diagram, and reverse secondary crank diagram. Okay, as there are 3 cylinders, so what is the position of cylinder number 1, 2, 3? That we have to fill up here now. Okay, out of these 4 columns, first column is very important. Okay, here only you have to think somewhat. Once you fill up this first column, second, third, and fourth column is just mechanically you have to write down. Okay, so let us see how to write down the first column. Okay, for that purpose, you have to consider this primary crank diagram. See, there are 4 diagrams here, as I told you. Okay, these 2 diagrams are for primary crank. So this is primary direct crank diagram. This is primary reverse crank diagram. So this plus this will give you primary unbalanced force. Okay, then this is secondary direct crank diagram, and this is secondary reverse crank diagram. So this plus this will give you secondary unbalanced force. Okay, now see here, while referring, you have to draw this direct primary crank diagram using column number 2 of table. Okay, now see what is that concept. Now look here, this is your how you have written this direct this one. Okay, that means angles. These are nothing but the angles. Okay, so let us come here. Now see, here it is a crank. OA is the crank. Okay, then A1, say A2 and A3. Okay, these are the connecting rods, and O2, O3, O1, these are the line of stroke. Okay, now what you have to do, if you remember the concept of this direct and reverse crank, see what we did, this unbalanced force mr omega square cos theta, this is your primary unbalanced force. What we did, we have taken half of the mass and we have put it on the direct crank pin, and half mass we have put in the reverse crank pin. Okay, so right now we have to think only that this m/2, which is along the line of stroke, okay, we have to rotate it this through theta degree and put it at the crank pin. Okay, so this is your first column. For all 3 cylinders, we have to rotate m/2 such that mass should be at crank pin. Remember, there is only one crank. Okay, so this unbalanced mass we have to keep here. This unbalanced mass m/2 should be kept here, and for cylinder number 1 also, whatever this unbalanced mass m/2 is there, that also we have to keep here. Okay, now tell me, for cylinder number 1, okay, by what degree we should rotate this line of stroke so that it should be put at A, that is crank pin. See, it is already say parallel, okay, matching with this one. So we have to rotate cylinder number 1 by 0 degree. Therefore, we have written here 0 degree, okay, because this is already in this, the angle is same. Okay, so what we have to write down, or what we have to analyze, that rotating m/2 by 0 degree such that it should be kept at crank pin OA for cylinder number 1. That's why we have written here 0 degree. Okay, now consider cylinder number 2. This is your line of stroke. So here your unbalanced primary force is lying. So you have to rotate this m/2 and keep it at A in the direction of rotation of the crank. Your crank is rotating, see, omega is seen clockwise. So you have to rotate this m/2 mass to put here at A. So how much degree you have to rotate? See here, this is 120. Okay, so that's why we have written here 120. Okay, now let us consider cylinder number 3. Unbalanced primary force is lying here. That means m by 2 we have to pick from here, okay, and I have to keep it here. So by what degree I should rotate this in the direction of omega, that is clockwise? So I have to rotate it through 240 degree so that I can keep it here. Understood? So that's why it is this angle is 240 degree. That's why we have written here 240 degree. Understood? So this is direct primary crank angle. Okay. Now what is reverse? See again this concept. Go to your this diagram. Reverse means it is exactly opposite to the theta, that is minus theta. Okay, if this is clockwise theta, this is minus clockwise. So m by 2 now you have to keep here at the reverse crank pin. That means I have to rotate this unbalanced mass m by 2 by minus theta degree. Okay, so what should I do? There are 3 cylinders. Okay, so here you have to just write down or give negative sign to all these 3. 0 is already 0, there is no negative positive. 120, I will give the minus sign, minus 120, and 240, minus 240. Understood? So reverse primary crank will be rotated through 0 degree, minus 120 degree, minus 240 degree. Okay. Now go to secondary crank. Okay. So you know that for secondary crank, what is the image? It is an imaginary crank. Okay, which is having the same mass, which will rotate by double speed, and which will be covering the angle by two times, that is 2 theta. Okay, so 2 theta means, now see, this is your direct crank, this is also your direct crank, but this is secondary, this is primary. So just make double angle of this direct primary crank and write down here. So 0 into 2, 0. 120 into 2, 240 degree. 240 into 2, 480 degree. 480 minus 360, it is 120 degree. Understood? So this is the direct secondary crank angles. We have to rotate that m by 2 to put it on the direct crank, on the secondary direct crank. Okay. Now this is reverse secondary crank. And you know, again the same concept. Whatever the direct crank rotation angle is there, you have to just rotate reverse crank in the opposite direction. Okay. So 0, it is minus 0 means 0. 240, it is minus 240. 480, it is minus 480. That means minus 120. Okay. So again, I will explain you. Only this column is important. Remaining things are just mechanically you have to fill up. Okay. How to write down this angle? See, again, I will explain here. Where is your crank pin? Here at A. Okay. So I have to bring this unbalanced primary mass, that is m by 2. Okay. For direct crank at A. Okay. Now here this unbalanced primary m by 2 mass is parallel to this one. So I have to rotate by 0 degree for cylinder number 1. That's why I have written 0 here. Okay. Then consider the line of stroke for cylinder number 2. Okay. Here unbalanced force is lying. So I have to rotate this m by 2. Okay. So that it should be kept here at direct crank pin. And how much is this angle? 120. Okay, in the direction of rotation. That's why I have to write down here 120 degree. Now, this is line of stroke for cylinder number 3. So here it is unbalanced force and here it is unbalanced mass m by 2. I have to keep it here now. So I have to rotate this by how much degree to keep it here in the direction of rotation? This is 240 degree. That's why this is the 240 degree for cylinder number 3. Okay. Now for reverse, what you have to do? Just give the negative sign for this angle and write down here. So 0 is 0 only, 120 ka minus 120, 240 is a minus 240. Okay. Then what is the secondary crank? Similar concept you have to follow. You know, but the angle is double. So just make the double angle of this one and write down here. 0 into 2, 0. 120 into 2, 240. 240 into 2, 480. That is 120 degree. Okay. Then what is the reverse secondary crank? Just give the negative sign to this one. That means you have to rotate in the opposite direction. So 0 is 0. 240, it is minus 240. 480, minus 480. Understood this table? Now, according to these 4 columns, I have to draw these 4 diagrams. Okay, so let us consider this first diagram, that is direct crank primary. Okay, so where is our cylinder number 1? Here already. Okay, I have to rotate it by 0 degree. Okay, now you have to refer this first column. This is first column. So let us just remember, cylinder number 1 I have to rotate by 0 degree, cylinder number 2 I have to rotate by 120, and cylinder number 3 by 240 degree. And these are the positions, cylinder number 1, 2, 3. Okay, so consider this diagram. Okay, so I have to rotate cylinder number 1 by 0 degree. So it will remain here only. So I have written m by 2. Okay, then cylinder number 2, we have to rotate by 120 degree in the direction of rotation, that is clockwise. Okay, so it will also come here. So this m by 2 is for cylinder number 2. Then cylinder number 3, I am rotating through 240 degree. It will also come here. Okay, in the direction of rotation. So here also m by 2. So what has happened now? All these m by 2, m by 2, m by 2 has gathered here. Okay, so m by 2, m plus m by 2 plus m by 2. All masses are concentrated here. Okay, we will analyze this later on. Okay, now let us go to second diagram now. Reverse crank primary. Okay, which column you have to refer? Column number 3. This one for reverse crank diagram. So you have to rotate cylinder number 1 by 0 degree, cylinder number 2 by minus 120, means in the opposite direction of omega, and cylinder number 3 by minus 240, means in the opposite direction of omega. Okay, now let us study this diagram. Reverse crank primary. Okay, now these are your cylinder number 1, 2, 3. Okay, now cylinder number 1 you have to rotate by 0 degree, so it will remain here only. Okay, now cylinder number 2, you have to, cylinder number 2 is here, you have to rotate it by 120 degree in the opposite direction. See, this is your regular direction, this is clockwise is your actual direction, but we have to rotate it by in the opposite direction, that means anti-clockwise. Your cylinder number 2 is here. Okay, so 120 degree it will be rotated in the opposite direction, that is anti-clockwise, it will come here. So m by 2 has come here. Okay, then cylinder number 3 is here. You have to rotate this m by 2, okay, in the opposite direction by 240 degree angle. Okay, minus 240 degree. That means in this direction, and it will come here. Okay, so all three masses are again making 120 degree angle because of this rotation of the reverse crank diagram. See this one. Okay, so again I will be telling you reverse crank diagram how to draw. You have to rotate this crank means line of stroke. Okay, how to remember line of stroke? You have to rotate by these angles in the opposite direction of the omega. Okay, so where is the line of stroke of cylinder number 1? This one. You have to rotate it by 0 degree, it will remain here only. So m by 2, 1 m by 2 is here. Cylinder number 2 is here. This is your line of stroke. You have to rotate it in the opposite direction, that is anti-clockwise by 120 degree. So this m by 2 will come here. And then cylinder number 3, this is your line of stroke. You have to rotate it in the opposite direction by 240 degree. So it will come here. So m by 2, m by 2, m by 2. Okay, we will analyze it later on. Now let us draw this secondary direct crank. Okay, how to draw this? What you have to rotate? By which angle you have to rotate? See, you have to refer column number 4. So direct secondary crank. You have to rotate line of stroke for cylinder number 1, 2, 3 by 0 degree, 240 degree and 120 degree in the direction of omega. Understood? So let us draw this secondary direct crank diagram now. Here your cylinder number 1, 2, 3. Now what I told you, cylinder number 1, that is line of stroke of cylinder number 1, you have to rotate by 0 degree. Okay, that means it will remain here. So m by 2 will be here. Then cylinder number 2, you have to rotate by 240 degree in the direction of omega. So it will come here, m by 2. Then cylinder number 3, line of stroke, you have to rotate in the direction of rotation through 120 degree. So it will come here. Okay. So again, 1 m by 2 here, 1 m by 2 here, 1 m by 2 here. This is your secondary direct crank diagram. Okay. Now let us draw this reverse crank diagram for secondary crank. You have to refer last column, that is column number 5, this one. Okay. So what you have to do, you have to rotate cylinder number 1, 2, 3 by angle 0, 240 and 120 in the opposite direction of omega. Okay. So let us see here. Fourth diagram. Okay. See, cylinder number 1, 2, 3 are here. Now, cylinder number 1, you have to rotate by 0 degree. So it will remain here, m by 2. Okay. Then cylinder number 2, you have to rotate by 240 degree in the opposite direction. Okay. Sorry, opposite direction. Cylinder number 2, opposite, what is the angle? Sorry, I will just see. Cylinder number 240, minus 240 degree. Okay. So, see here. So, cylinder number 2. So, this is your normal rotation. Okay. Omega. So, this will be reverse, means in this direction. So, cylinder number 2 line of stroke, you have to rotate by 240 degree in the opposite direction of omega. It will also come here. So, this is m by 2 for cylinder number 2. And then cylinder number 3, you have to rotate in the opposite direction, that means anti-clockwise by 120 degree. So, it will also come here. Okay. So, all three masses are again gathered together at position number 1 at the crank. Okay. So, now let us analyze one by one. Let us first find out how much is the unbalanced force present at the direct crank primary crank. Okay. So, what is by observation? See, all m by 2 plus m by 2, all three masses are gathered here. Okay. So, what is your primary force magnitude? Mr omega square. Mr omega square cos theta basically, but we consider only maximum magnitude. Okay. So, let us find out now. So, this procedure I have written so that you can understand. Procedure to draw secondary crank diagram. Okay. And here we have written all procedure I have written here. See, procedure to draw primary crank diagram. So, how to draw primary direct crank diagram? These are the 4 steps. Then how to draw primary reverse crank diagram? These are the 4 steps. Then the procedure to draw secondary crank diagram. So, this is secondary direct crank diagram procedure. And then this is secondary reverse crank diagram procedure. Okay. After that, we have to analyze for all 4 diagrams. So, first calculating primary direct unbalanced force. Okay. What is your unbalanced primary force magnitude? You know, it is Mr omega square. Okay. But here for primary crank, there is only m by 2, no? Every mass we have made half and half. So, all 3 masses are gathered together. So, 3 is for all 3 masses. Every mass is m by 2 and r omega square. So, what is the primary direct unbalanced force? 3 m by 2 r omega square. So, put the value of m 1.53 kg, put the value of r 0.05 meter, put the value of omega. Okay. You will get primary direct unbalanced force. Okay. Then calculating reverse primary unbalanced force. Okay. For this purpose, you have to refer this second diagram. See this one. Okay. Now see, from this diagram, what you observe that the forces are balanced. See, this m by 2 will create centrifugal force in the upward direction. Then this is in this direction and this is in this direction. If you resolve this into 2 components, this is horizontal component, this is horizontal component, this will balance with each other, horizontal component. Then this is vertical component, this is vertical component which are at certain angle. See, this angle is 30 degree. Okay, so this sine component plus this sine component will be balanced by this component. So there will be 0 unbalanced force for primary reverse crank. Okay, so that we have written here. See, by simply observation, primary reverse crank diagram, we see that there is no unbalanced primary reverse forces. So FPR is equal to 0. P for primary, R for reverse. Okay. So what is the total primary unbalanced force now? Primary direct unbalanced force plus primary reverse unbalanced force. So total primary unbalanced force is FPD plus FPR. Okay. So this plus 0. This is your total primary unbalanced force. Okay. That is 11,318.69 Newton. Okay. Similarly, we find out secondary unbalanced force based on diagram, these two diagrams. See here. Okay. Now let us study this diagram. Again, what has happened here? See, this centrifugal force, which is in the upward direction, will be balanced by this sine component plus this sine component. It will be balanced. The horizontal component of cylinder number 2 will be balanced by this horizontal component. That means there is a zero unbalanced direct secondary force. Okay. Now, let us analyze this one. What is the magnitude of secondary unbalanced force? Mr omega square upon n. Okay, but there are three masses, m by 2 plus m by 2 plus m by 2, because we have made it half. Okay, so it will be 3 into m by 2 r omega square upon n. Okay, because all are gathered together. So how to calculate secondary reverse unbalanced force? See here. So it is, 3, because there are 3 masses. Mass is m by 2 into, what is the crank length? R upon 4n into speed is double, that is 2 omega bracket square. Or you can also simply write down, because this 4 will cancel with this 4. Okay. So what you can write down? 3 into m by 2 r omega square upon n. R omega square upon n. Okay. So say reverse secondary crank unbalanced force is 3 by 2 mr omega square upon n. Okay. Put the value of m, r, omega and n. You will get secondary reverse unbalanced force is 772.89 Newton. And what is direct force? Already we have seen by simply observation of secondary direct crank diagram. We see that there is no unbalanced secondary forces, because the forces are balanced with each other. So what is the total secondary unbalanced force? This number 3 plus number 4. So 0 plus 377.89. This is your total secondary unbalanced force. Understood? Is it not very easy method? You don't have to draw any couple polygon, force polygon. That means if you have studied that to balance the inline, multi-cylinder inline engine, you had to draw 4 diagrams. Primary force diagram, primary couple diagram, then secondary force diagram and secondary couple diagram. Okay. But for this multi-cylinder radial engine, you don't have to draw any couple polygon or any force polygon, because forces you can find out unbalanced forces by simply this 4 cranks diagram. Okay. And using that table. Okay. And once you balance these forces, couples will be automatically get balanced, because all these forces are acting at a single plane. See here, this is single plane. Now here your shaft is perpendicular to your say screen. Okay, so this is your shaft and your planes are, this is your 1, 2 and 3 cylinders. So all 3 cylinders are in one plane, making radially angle 120 degree with each other. So if your forces are balanced, your couples will be automatically balanced. So there is no need to check the couple balancing in radial engine. Understood? So there exists only balancing of the forces, that is primary force and secondary force. Understood? Now let us go to second problem. Problem number 2. In a 60 degree V engine, 2 connecting rods operate on a common crank pin. So there are only 2 cylinders now, making angle 60 degree with each other. Okay. Stroke of each piston is 80 mm. The length of each connecting rod is 160 mm. If the engine speed is 2000 rpm and the mass of the reciprocating parts per cylinder is 1 kg, find the values of maximum primary and secondary force unbalance when the crank bisect the line of action of forces by 30 degree. That means what? See, this diagram is given. This is cylinder number 1. This is cylinder number 2. Okay. And crank is exactly bisecting at this instant. Crank is exactly bisecting two line of stroke. That is, crank is vertically along YY axis, and the angle, it is 60 degree V angle, means V engine means the line of stroke of both the cylinders are at 60 degree. So from crank, line of stroke of cylinder number 2 is at 30 degree, and line of stroke of cylinder number 1 is also 30 degree. So this is a common crank. Okay. Now, what is the given data? Let us have the look here. So 2 alpha is 60 degree. Okay. Stroke is 80 mm. That means crank radius is 0.04 meter. Length of the connecting rod is 0.16 meter. Then N, that is obliquity ratio, L upon R, that is 4 L upon R. M is equal to 1 kg. Speed is 2000 rpm. So we find out omega, that is 209.44 radian per second. And we have to find out unbalanced primary force and unbalanced secondary force. Okay. Now what is the first step? Prepare the table. Again, there will be 5 columns. Column number 1 gives position of cylinders. So cylinder number 1, cylinder number 2. Then this column is direct primary crank angle, reverse primary crank angle, direct secondary crank angle, reverse secondary crank angle. Okay. Now again, you have to write down only this column. It is very important. Okay. See, what do I have to do now? Look here. This is cylinder number 1. Okay. So what is the concept? You have to bring this M/2, which is falling on the line of stroke. So you have to rotate this line of stroke in the direction of omega, that is clockwise, so that M/2 can be placed at crank pin. So tell me, how much is this angle? I have to rotate this line of stroke by this angle. See, this is 30 degree. So this remaining angle is 330 degree. Correct? 360 minus 30. So that's why we have written here 330 degree. Okay. Now, for cylinder number 2, this is your line of stroke. So M/2 is at line of stroke. So I have to keep this M/2 at this crank pin. So as it is a direct crank, I have to rotate this M/2 through how much angle, so that it should be kept here in the direction of rotation, that is clockwise. So it should be rotated by 30 degree, so that this M/2 should be kept here. Okay. That's why here we have written 30 degree. Understood? So once we get this direct primary crank angle 330 degree and 30 degree, how to write down reverse primary crank angle? Just give the negative sign, because it's a reverse angle. So we write down here minus 330 and here minus 30. Okay. How to write down direct secondary crank? Just make double of this angle. 330 into 2, 660. Minus 360, one rotation completed, it is 300 degree. How to write down this one? 30 into 2, that is 60 degree. Okay. So now how to write down reverse secondary crank? Just give the negative sign here. So it is minus 660 and this is minus 60. Okay. Now based on these 4 columns, you have to draw 4 diagrams. Okay. Let us draw first direct primary crank diagram. What you have to do? You have to rotate cylinder number 1 M/2 by 330 degree in the direction of omega, and cylinder number 2 by 30 degree in the direction of omega. Okay. So this is your direct primary crank diagram. Cylinder number 1 is here. Cylinder number 2 is here. Okay. So what you have to do? You have to rotate line of stroke of cylinder number 1 through 330 degree in the direction of rotation. So M/2 will come here. So this M/2 is for cylinder number 1. Then you have to rotate cylinder number 2 line of stroke by 30 degree in the clockwise direction. It will also be coming here. So both the masses are concentrated here, M/2 plus M/2. Okay. Now let us analyze this second. That means reverse crank primary diagram. What are the angles? See this column. So we have to rotate cylinder number 1 line of stroke by 330 degree and cylinder number 2 by 30 degree in the opposite direction of omega, that is anti-clockwise. Okay. So now see, your cylinder number 1 is here, cylinder number 2 is here, and your clockwise is the actual direction of rotation. So here we have to rotate by anti-clockwise direction. Now cylinder number 1 we have to rotate by 330 degree angle. Okay. So in the opposite direction 330 degree it will come here. Okay. So m by 2 will be coming here, which is making angle 30 degree to positive x-axis. Okay. Then cylinder number 2 line of stroke I have to rotate by 30 degree in the opposite direction, that is in the anti-clockwise direction. So 30 degree means it will come here. So 1 m by 2 is here, 1 m by 2 is here. Okay. These forces we will analyze later on. Now let us draw this secondary direct crank diagram. Okay. By what angle we should rotate? Refer column number 4. So you have to rotate cylinder number 1 by 300 degree and cylinder number 2 by 60 degree in the direction of omega. So see, your cylinder number 1 is here and cylinder number 2 is here. So you have to rotate line of stroke of cylinder number 1 by 300 degree in clockwise direction. 300 will come here. Okay. So here m by 2 will come. Then cylinder number 2 is this line of stroke. You have to rotate it by 60 degree in the clockwise direction. So it will come here. So 1 m by 2 is here, 1 m by 2 is here. Okay. We will analyze the forces later on. Now let us draw this reverse crank diagram, secondary. What angle you have to refer? For column number 5. So cylinder number 1 line of stroke to be rotated by 300 degree in the opposite direction of omega, that is anti-clockwise, and cylinder number 2 line of stroke you have to rotate by 60 degree in the opposite direction of omega. Okay. So see, this is your cylinder number 1 line of stroke. You have to rotate it by 300 degree in the opposite, that is anti-clockwise direction. Okay. So this is 330, no? So 300 degree it will come here. Okay. So m by 2 will come here. Then you have to rotate cylinder number 2 line of stroke by 60 degree. Okay. So in the opposite direction, that is anti-clockwise. So by 60 degree rotation it will come here. Okay. So 1 m by 2 is here, other m by 2 is here. Now by observation you will see that these two forces are balanced. Okay. Now let us analyze let us calculate the unbalanced forces now. So let us analyze primary direct crank. See, both the masses are here gathered here. Okay. Now as this is primary unbalanced force, what is the magnitude? mr omega square. As there are two masses, it will be 2 into m by 2 r omega square. Okay. So let us analyze this. Let us find out. Calculating primary direct unbalanced force, which is given by mr omega square. But your m is m by 2 and there are 2 m by 2, two masses. So 2 m by 2 r omega square. Okay. Put the value of m, that is 1 kg. Put the value of r, that is 0.04 meter, and omega. You will get primary direct unbalanced force 1754.60 Newton. Okay. Similarly, calculate this reverse primary unbalanced force. See, these two masses are here. Now this you have to resolve this mr omega square by 2 into vertical component and horizontal component. Similarly, this force also into vertical component into horizontal component. What will happen? This horizontal component, see, this angle is 30 degree. Okay. So the horizontal component is mr omega square by 2 into cos 30. Okay. And this is also mr omega square by 2 into cos 30. So this component of force will be balanced by this component of force. Okay. So what is remaining now? This vertical component, which is sine component, plus this vertical component, which is also sine component. So this plus this will give you unbalanced reverse primary force. So how much it is? Mr omega square by 2 sine 30 plus Mr omega square by 2 sine 30. Okay, so it is written here. The horizontal component of primary reverse crank unbalanced forces cancel with each other, but vertical components of primary reverse crank unbalanced forces are calculated. It is two component which are same, m by 2 r omega square sine 30. I have written here cos 30, cos 60, one and same thing, okay? Because I have considered 60-degree angle. So cos 60, okay? So put the value of m, put the value of r, put the value of omega. How much you will be getting? Magnitude is 1029.95 primary reverse unbalanced force. Okay. Then how much is total force now? See here, total unbalanced force is this 175, the primary direct force plus primary reverse force. So this plus this will give you total primary unbalanced force, that is 2784.55 Newton. Okay. Now let us analyze secondary forces, secondary unbalanced forces. How much is the force here? Again, as one mass is 1 m by 2 here, 1 m by 2 is here, resolve. So this is the centrifugal force, unbalanced force in this direction. Resolve it into two component, horizontal, vertical. Okay, horizontal component is cos 60 or sine 30. You can say either if you consider this angle, it will be sine component. If you consider this angle, it will be cos component. Then again, this force also you consider two component, vertical component, horizontal component. So this horizontal component will be balanced by this horizontal component. Okay. And what is the magnitude of secondary unbalanced force? Mr omega square upon n. Or you can write down m r upon 4n into 2 omega square. Okay. So these two components are balanced. What is remaining now? The vertical component of this cylinder and vertical component of this m by 2. This plus this will give you total unbalanced direct secondary force. Okay. So how much is it? See, this is your calculating secondary direct unbalanced force. Okay. There are vertical component now. The horizontal components of secondary direct crank unbalanced forces cancel with each other, but vertical component of secondary direct crank unbalanced forces are calculated as follows. So there are two components. So 2, and what is the magnitude? Mr omega square upon n into cos 30, or sorry, m by 2. It's not m. So m by 2 into radius of the crank is r upon 4n into speed is double 2 omega. If you cancel this 4 with this 4, it will be m by 2 r omega square into cos 30. So put the value of omega, cos 30, r, n, m. You will get magnitude 390.83 Newton. This is secondary, sorry, not primary. I forgot here. It should be secondary here, SR. So secondary reverse. Okay, this is secondary reverse. This one. Okay, calculating. Sorry, direct. It should be secondary direct crank. Please make this correction. This is secondary direct unbalanced force. So here it should be SD. Okay. Now what is secondary reverse unbalanced force? Go to this diagram. See, this is secondary reverse unbalanced forces. There are no unbalanced forces because this m by 2 r omega square upon n will be balanced by m by 2 r omega square upon n. Okay. So what is the total reverse unbalanced force? See here. This is 390.83 and this is 0. So FSD plus FSR is equal to 390.83. Okay. So like this, we can find out secondary and primary unbalanced forces by using direct and reverse crank method. The same problem can be solved by analytical method. If you remember, V engine we have studied. This is nothing but V engine, V60 angle. Okay. So what is the total primary force along YY? You can resolve this component into vertical now, vertically. We have studied this already. Okay. So FPY, that is primary force along Y direction, is given by 2 Mr omega square cos square alpha into cos theta. How this formula has come, that we have already studied in the earlier lecture. Okay. So either you again solve this problem by say first principle, or you remember this formula. But of course, in the examination, they will not tell you that solve the problem by analytical method only. You can adopt any method. And I will suggest you that don't adopt analytical method, because there are chances of wrong calculations or mistakes in the calculations. Plus, you have to remember these four formulae. Primary, say, unbalanced force along y direction. Then primary force in the along the x direction. This is other formula. Similarly, for secondary also. For secondary force along y direction, this is the formula. And for secondary force along the x direction, this formula. And you have to finally add it, vector addition. Okay. So this is just for your, you can solve it at home. Okay. Answers will be exactly same. Okay. This is the whatever we have got from the direct and reverse crank method. Same answers are there. Somewhat mistake is there. I don't know what is the this one. In by direct and reverse crank method, this answer is 390, and here I am getting 458. Okay, somewhere I may be wrong in the calculations. Okay, you find out that my mistake. Okay, now let us go to problem number 3, the last problem. Okay, in a 3-cylinder engines, axes of cylinders are coplanar, that means in one plane, and angles between the neighboring axes are 60 degrees. All cylinders drive same crank of length 220 mm. Each connecting rod is 850 mm long. Reciprocating mass per cylinder is 1.5 kg and engine runs at 1200 rpm. Find primary and secondary direct and reverse unbalanced forces. Okay. So by this time now you are familiar with the procedure. Okay. So what is the given data? Radius of crank 0.220 meter. Radius of, length of connecting rod 850 mm. So N is 3.86, M is 1.5 kg, N is 1200 rpm. So omega is 125.66 radian per second. We have to find out primary unbalanced force and secondary unbalanced force. Okay. This is the diagram. See, these are 3 cylinders. Cylinder number 1, 2, 3. And your crank is lying parallel to line of stroke of cylinder number 2. Okay. So again, you have to prepare this table. Okay. There are 3 cylinders. 1, 2, 3. So this is your column number 1, which gives position of 3 cylinders. 1, 2, 3. Okay. Now, you have to write down direct primary crank angles. What you have to do? You have to bring m/2 from line of stroke of all 3 cylinders to keep at the crank width. Okay. So cylinder number 1, here is your line of stroke. Direction of rotation of omega is clockwise. Okay. I have to bring this m/2 and keep here. So what should the angle by which I should rotate this? 60 degree. That's why we have written here 60 degree for cylinder number 1. Then cylinder number 2, see, this is parallel to already this line of stroke. So you have to rotate it by 0 degree. Okay, because already it is parallel to this line of stroke. So cylinder number 2, you have to rotate by 0 degree. Now let us go to cylinder number 3. See, here it is line of stroke of cylinder number 3. You have to rotate this m/2 in the direction of rotation so that it should come here. So how much is this angle? 300. Okay. So we have written here 300. Understood? Now, how to write down this reverse primary crank angles? As it is reverse, just give the negative sign. So minus 60, 0, minus 300. Okay. Now, how to write down these direct secondary crank angles? Just make double of this direct primary crank angle. 60 into 2, 120. 0 into 2, 0. 300 into 2, 600. That is 600 minus 360 is 240 degrees. Okay. How to write down this reverse secondary crank angle? Just give negative sign to direct secondary crank angle. So this is minus 120, this is 0, and this is minus 600, that is minus 240. Okay. Now you have to draw this 4 diagram. Let us first draw this primary direct diagram. You have to rotate cylinder number 1 by 60 degree, 2 by 0 degree, 3 by 300 degree in the direction of omega, which is clockwise. Okay. So this is your diagram. Okay. Cylinder number 1 is here, line of stroke, 2 is here, 3 is here. Okay. Now cylinder number 1, you have to rotate by 60° clockwise. So it will come here. So 1 m by 2 is here. Cylinder number 2, you have to rotate by 0°. So it will be already here. Then cylinder number 3, line of stroke, you have to rotate by 300°. It will also come here. So all the masses are concentrated here, m by 2 plus m by 2 plus m by 2. Okay. Then draw this reverse crank primary diagram. What are the angles? See here, you have to refer column number 3. Okay, what are the angles? You have to rotate cylinder number 1 by minus 60, that is 60°. This is 0°, and this is 300° in the opposite direction of omega. So 60, 0, 300. See here, here. This is your cylinder number 1, 2, 3 position. Okay, you have to rotate cylinder number 1 in the opposite direction, that is anti-clockwise, by 60°. By 60°, so it will come here. So here it is m by 2. Okay, then cylinder number 2 by 0°, so it will remain here only. Cylinder number 3 by 300°, it will come here. Okay, so m by 2, m by 2, m by 2. Okay, now let us draw this direct secondary crank diagram. You will refer column number 4, that is direct secondary crank diagram. So you have to rotate cylinder number 1, 2, 3 by what angle? 120, 0, 240 in the direction of omega. Okay, so go to this diagram. These are your cylinder number 1, 2, 3 line of stroke. Okay, so you have to rotate in this clockwise direction cylinder number 1 by 120° angle. So it will come here. Cylinder number 2 line of stroke by 0° angle, it will remain here. And cylinder number 3 in the direction of rotation by by what angle? 300 angle, no? No, sorry, 240. Let us see, I forgot. 240. Okay, so here it is. This cylinder number 3, you have to rotate by 240° angle, it will come here. Okay, so m by 2 here, m by 2 here, m by 2 here. Okay, now you have to draw secondary reverse crank diagram. What are the angles? See here, 120 and 240 in the opposite direction. Okay, that is anti-clockwise. So this is your line of stroke of cylinder number 1, 2, 3. Now you have to rotate cylinder number 1 line of stroke anti-clockwise by which degree? 240°. Okay, so that it will come here. Okay, minus 240, no? So it will come here. Then cylinder number 2, cylinder number 2, you have to rotate by 0°. So it will remain here only. Sorry. Cylinder number 120. Yeah, sorry, 120. You have to rotate it by 120°. So cylinder number 1 by 120°, so it will come here. Okay, this is your m by 2. Cylinder number 2, 0°, it will remain here. Cylinder number 3 by 240°. So this is 120, this is 120. It will come here. So two masses are concentrated here, m by 2 plus m by 2. One mass is here. Okay. Now let us calculate the magnitude of these forces. What is the magnitude of primary unbalanced force? Mr omega square. So here all three masses are there. So 3 into m by 2 into r omega square. Okay, let us calculate. Calculating primary direct unbalanced force. 3 m by 2 r omega square. Putting this value, we are getting 7816.76 Newton. Okay. Now for primary reverse, there will be zero unbalanced force. Okay, because these will see the horizontal component of this force will be balanced by this horizontal component. Okay, and then vertical component of sine sine 30 plus vertical component of sine 30 will be balanced by this one. So this is exactly equal to this plus this. So there will be no unbalanced force. So total primary unbalanced force will be direct force plus reverse force. Okay, which will be, this will be 0. So only direct force will be total unbalanced primary force. Okay. Now let us analyze secondary direct unbalanced force. See, 3 masses are here. So this again, this force is in this direction, this force is in this direction, this force is vertically direction. Okay. So the horizontal component of this force will be balanced by horizontal component of this force. Okay. Now what is remaining? This vertical component plus this vertical component, that is sine 30 of sine 30, and plus this is the vertical component. What is the magnitude of secondary unbalanced force? mr omega square upon n, or m into r by 4n into 2 omega bracket square. Okay, so we have to add this, and these are having same magnitude. So we can write down 2 into m by 2 r omega square upon n plus m r omega square upon 2n. Okay, so let us write down here direct secondary crank. Okay, so total primary force is this one. Now calculating secondary direct unbalanced force. The horizontal component of secondary direct crank unbalanced forces cancel with each other, but vertical components of secondary direct crank unbalanced forces are added. Okay, so FSD is equal to, now there are two components, so 2 into m by 2 into r upon 4n into 2 omega bracket square into cos 60 plus that cylinder number 1, its vertical component will be, it is acting in vertical direction only, so it will be m by 2 r upon 4n into 2 omega square. Okay, so this is mr omega square upon 2n, this is mr omega square upon 2n, so it will become mr omega square upon n. Putting the value, we will be getting secondary direct unbalanced force 1348.56 Newton. Okay, now let us find out secondary reverse unbalanced force. See this diagram. Okay, see this m by 2 is acting in the vertically upward direction. What is the secondary unbalanced force created by this m by 2? You know what is the magnitude of secondary unbalanced force? mr omega square upon n. So here it will be m by 2 r omega square upon n. What is the magnitude of this force? Here there are two masses. So 2 into m by 2 r omega square upon n. But this is acting in the vertically upward direction. This is in the downward direction. So this minus this is the total vertical unbalanced force. So let us calculate it. Secondary reverse unbalanced force. Okay. So FSR, secondary reverse unbalanced force, is equal to, this is vertically upward, m by 2 r upon 4n into 2 omega bracket square, or you can write down m by 2 r omega square upon n, if this 4 will be cancelled, minus, because this is acting downward, there are 2 m by 2, so 2 into m by 2 r upon 4n into 2 omega bracket square. Okay, so mr omega square upon 2n minus mr omega square upon n. This will give you minus mr omega square upon 2n. Okay, minus means it is acting downward, because positive direction we have considered upward, but it is coming minus, so your total unbalanced force is acting downward direction. So putting the value of m, r, omega and n, we will be getting minus 674.28. Okay, so what is direct secondary force? 1348.56, which is upward. And what is direct reverse secondary force? Minus 674.28. So this minus this is total secondary unbalanced force, that is 674.28. Okay, so I hope you understood this problem. See, these problems are actually very, very easy, but you must understand the concept on which this is based. What is important, I will just revise whatever we have learned in 2 minutes. Okay, because right now we have solved 3 problems. So I hope you have understood all the procedure. Okay, so let us revise what we have learned. For example, this one only. So what is the step 1? Okay, you have to prepare this table. For this table, only the first column, the second column, that is direct primary crank only, is very, very important to think and to write it. Okay, how to write down it? Every line of stroke you have to rotate in the direction of omega, so that m by 2 should be kept at crank pin. Okay, by doing this you will write down this column. Reverse primary crank, just give the minus sign. Direct secondary crank, make the double of this one. Reverse secondary crank, just give minus sign for this column. Understood? Once you prepare this table, then you have to draw 4 diagrams. What are those 4 diagrams? Okay, direct primary crank diagram, reverse primary crank diagram. So this plus this will give you total primary unbalanced force. Then draw direct secondary crank diagram, reverse secondary crank diagram. This plus this will give you total secondary unbalanced force. And how to, again, first you have to write down these 3 original position. Cylinder number 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then you rotate these m by 2 using this column of this table, respective column, and just see where your m by 2 will be going. For example, here all m by 2 are concentrating here. In this diagram, m by 2 will be placing here, here, and here. Here also, this will be taking this position, and here this will be taking this position. So by simply your calculating or knowing this m, r, omega square and n, you can calculate the magnitude of these forces. So what is the magnitude of unbalanced primary force basically? What is the formula? mr omega square. Okay, but here we are half only mass considering for direct, half will be for reverse. So it is m by 2. Okay, and what is the formula for secondary unbalanced force? mr omega square upon n. But again we are considering m by 2. So here it will be m by 2. Okay, and radius will be r upon 4n and speed will be double, or you can simply cancel these 4. You can write down mr omega square upon n for secondary unbalanced force. Okay, I hope you understood everything. Now, unless and until you solve this problem in your notebook by your own hands, you will not understand, or you will not be able to solve it in the examination. Okay, so please solve all these 3 problems in your notebook. Okay, solution is in front of you. Then and then only I will consider that you have understood all these problems thoroughly. Okay, so thank you very much. Here we have finished unit number 4, that is balancing unit completely. Okay, so we have studied balancing of multi-cylinder inline engines, and we have studied balancing of radial engines, and before that one we have also studied balancing of rotating masses. Okay, so these are all graphical methods. Thank you very much.